We're now going to take a look at the geometric mean within these right triangles that we just saw that they were similar to. So we have two theorems. One is the geometric mean altitude theorem, and the other one is down at the bottom. That is called the geometric mean leg theorem. We're mostly going to deal with the altitude theorem. I'm going to show you where it comes from and then how it kind of works. So really we can, since all these triangles are similar, we can create proportions out of this. So that's what we're going to do. I'm going to create a proportion that deals with x, h, and y. So if I look at this triangle right here, it looks like x is smaller than h on this triangle. So I'm going to go small leg over the big leg is equal to, since that triangle is also similar to this triangle, I should be able to create a proportion. Now it looks like h is the smaller one in comparison to y. So we would go h over y. Again, we would cross multiply this. We would get h squared equals xy. And then square root, we would get h equals the square root of xy. In other words, the altitude, h, is the geometric mean between x and y. So this is what we're really going to use. The one on the bottom is a little bit harder to see. This one we're going to call the the leg theorem. Okay, so just to try and show you what this one looks like. This time you're going to use a smaller triangle and the whole thing. So I'm going to say let's focus on this triangle first. Notice that x is a leg and b is the hypotenuse. Okay, so I'm going to go leg over the hypotenuse, b. Now you're going to look at the big triangle. When we look at the big triangle, now we're looking at the whole thing. And if I look at this one, again, I'm still focused on this leg over here. Now b, which was the hypotenuse of this smaller one, is now the leg of this entire triangle. So we're going to say b over the hypotenuse of this triangle is c. Again, you can cross multiply and solve. It comes all the way out to b equaling the square root of x times c. You can see the locations on this one. b is equal to the square root of x and c. You do the same thing for a. A would just use this medium-sized triangle, and then the whole triangle again. We would say that a is equal to the square root of y times c. Okay, again, we're going to mostly use the top one, the altitude theorem. So, quick example, we're just going to do one of these, and we're going to do 3a. It asks us to find all three variables, x, y, and z. So in this case, the variable that we have to start with is z. We don't have a choice out of this. And remember, this is where that altitude theorem comes into. Z is the altitude, and it's splitting that long hypotenuse into two parts. So we would say that z is the geometric mean between 8 and 25. And when you plug this in, square root 8 times 25 is going to get you approximately 14.1. Once you have z, the rest of it's quite a bit easier. If I want to solve for x, I can highlight this triangle. Notice you have two sides of a right triangle, and x is the hypotenuse, so you can use the Pythagorean theorem here. So we can go 8 squared plus 14.1 squared equals x squared. And when you solve that, squared plus 14.1 squared, it gets you 16.2 for x. Likewise, you can do the same thing to solve for y. Now you're going to focus on the medium-sized triangle. You don't really have to, but I think it's easier than focusing on the whole thing. Now y is the hypotenuse, where 14.1 and 25 are your legs. So you'd have 14.1 squared plus 25 squared equaling y squared. And this will get you a total of 28.7 for y.